Welcome everyone to another Keptn user group. Today is Tuesday, February 16th. For those of you that are following what's typically going on a day like this, it's called Fat Tuesday here. We call it in Austria, we call it Faschingsdienstag. So it's kind of carnival, the last day of carnival, where we typically go out and party like crazy. Today the party is going to be a little smaller and a little more virtual, but still we have friends over. Roman, Christian, Jürgen, and I'm sure some attendees over there as well, Fabian and some others. So lai, or I don't know what else we should say.
I don't know either, Andy. Hi, thanks for the invitation. Glad to be here.
Hi, Andy.
Yeah. And I'm also very glad. I mean, Roman, we've been doing a couple of presentations over the last couple of weeks. You've always done an amazing job, but we always had to say, and now we have these exciting slides that have been heavily influenced by Christian, who is now also with us here. And that's great to have you.
Thanks, Andy.
Yeah. Really phenomenal. Cool. I want to just kick it off quickly. So the Keptn user group, this is really about the Keptn community talking about how they're using Keptn to solve certain use cases or how they're using it to make their lives better or to make the lives better of others that they help with Keptn and with their other services that they do. So it's a way to show Keptn to the community and explore different use cases. If you have any questions, either now or later on, feel free to put them into the chat window if you're live, or Jürgen has just posted the meeting doc. So feel free to put in your names, and I will also, especially later on when we get to Q&A, do some moderation here. But without further ado, Roman, you have been using Keptn, you and your organization, Triscon, you've been using Keptn over the last couple of months. And it's just phenomenal what you've been doing, especially around performance engineering. And so I really want to just now sit back and let you talk a little bit. I may interject from time to time in case I think it makes sense to have a little interaction and some questions. But other than that, I'm interested in hearing from you.
Feel free to interrupt me anytime. Yes, as you already mentioned, Keptn made also our life a lot easier, and today we're gonna focus entirely about topics around performance testing. So I'm gonna introduce this in a couple of slides in more detail, but we are all about performance engineering and performance testing and APM. And today I'm going to talk about how to scale performance tests by automating the result analysis, actually automating the entire process by using Keptn. First of all, let me quickly introduce us, so to say Triscon. I'm Roman from Triscon. Check us out on LinkedIn. Make sure to reach us out if you have any questions about performance testing. We are entirely dedicated to this topic. We do this for a lot of customers. And we also Dynatrace partners. We implement APM solutions, and we offer a lot of workshops and trainings. If you want to get a hand-on practice on Keptn, hands-on practice in a 2 to 3 days workshop, we can build some awesome automated quality gates, for instance. If you're listening to this and you may not be a performance tester, I want to just briefly discuss in one slide. I know it's not a lot, but I want to mention it, why it is so important to perform performance tests. So there's basically 3 pillars that you cover with performance tests. One is, of course, the stability topic. So you want to avoid crashes. You want to have the maximum security when you go live with a business critical application, that it won't crash once a certain amount of users are using your service. And this is the only way that you can achieve this is actually by running performance tests beforehand. So the stability issue is really important to uncover something nasty like memory leaks and stuff like that. Also, performance tests, as it says in the word, it's about performance, it's about speed. You want to ensure you meet your SLAs, that it's fast enough. You want to provide the best experience for your users. But this is actually only one aspect of performance tests. And the third one is the resource consumption, which is actually a heavy topic. It's becoming more and more important. If you move to the cloud, also performance tests are really important. There is also sometimes a wrong assumption, actually, that if you move to the cloud, you don't need performance tests because you can scale to endless limits, but you can also pay to endless limits. And actually also the scaling part itself does not always work the way you may think. It makes a lot of sense if you move to the clouds to run performance tests before and after you do it, to make sure that you have the best configuration, save some money, and that it actually works. And also, this is really brand new stuff. You also want to check out more legacy things like mainframe calls. We have this a lot, and we see that customers do a lot of outsourcing, or clients of ours do a lot of outsourcing, and the people who are sitting in the development teams, they may not be aware that in the 5th or 6th chain of their request, there may be mainframe calls backend there, which can cost a lot of money if you don't know about it. So these are the things that you may want to think about when you hear about performance tests. We do this for a lot of customers, and I brought you a story. If you want to check out what customer it is and learn more about the customer himself I'm talking about, you can watch our breakout session that I had with Andy together at the Perform. We talk a lot about that a little bit more in detail there. But in principle, I brought the story here. We have a big insurance company, and we managed in a couple of years to increase the test throughput and the apps that we support with performance tests by a factor of 10 to 15 in terms of tests. And we dare to taking the step to have a self-service. So really to get to the point where we reach performance test as a service and to enable other teams. But before we go this way, what are actually the challenges that every performance engineer is facing? I brought some of these as well. So usually, if you start with the topic, you don't start with a huge team. So if you're a performance engineer, it might be the case that you see yourself as a one-man show fighting against a lot of inquiries and trying to deal with the workload. So I have been there. It makes totally sense to put more awareness on this topic to get more resources. But what can you do if you're the one-man show? What helped us a lot to cover the needs and to cover the work is to go full into the topic of automation. And I'm going to talk about that, how you can help yourself to deal with all this amount of tests you may want to do. And script maintenance is also a big challenge. So a lot of time in performance testing is actually spent not for getting the valuable results out there and performing an analysis to gain more insights. A lot of time is still spent in script maintenance where you don't gain anything about it except time for actually being able to running your test. And you want to make this as small as possible, this amount of time. And that's why I'm going to also talk about the reusability of tests. And another part, I mentioned it already, is the result analysis. So you want to be as efficient as possible in the result analysis. And we are leveraging Dynatrace for the most awesome root cause analysis out there to have immediate feedback once we run our performance test, to have the information that the performance test has been run visible there in your APM tool so that others also know, oh, a performance test was run. This is why I see increased load on some applications and stuff like that. And how this is actually going to look in practice, I'm going to show you in a couple of minutes. So what was this story about the customer I already mentioned? When we arrived there in 2016, they were already doing performance tests, which is awesome. If you're doing performance tests, it's awesome. Yeah, keep doing it. It's really important. And they were doing it with more like a legacy approach, an older tool, Visual Studio Web Test Framework. In the meantime, it's not supported from Microsoft anymore. And we suggested to switch to a more elaborate tool. In this case, it was Neoload. And simply by switching tools, and some tools offer more, I say, neat things for test design, like frameworks, etc. I won't go into detail about that now, but we saved already about 30 to 50% for script maintenance just by switching to a better tool. And you gain a lot more also if you find yourself in this situation that you are recording the same test over and over again from one release to the other. You want to think about automating this process. And there is a high chance that someone else has automated a lot of tests in your company already with other tools maybe. So the first thing you want to think about is how can you integrate other test automation tools that may exist in your company already into your load test tool and save a lot of time for generating and maintaining your scripts there. We used, for instance, the Neoload Selenium integration and built our own Selenium framework. And the third part I mentioned, and we also did this at this customer side, was to become more efficient by using Dynatrace for our root cause analysis. It helps you to pinpoint the bottleneck as fast as possible. You don't need to run tests over and over again and changing some things in the system like load balancing to narrow down the problem, because you have full stack monitoring all the time across the entire landscape of your IT. And by combining all these measures, we ended up 3 years later with 10 times more tests or 15 times more tests and 10 times more applications that we were supporting. And we didn't use 10 times more people, and that's the effective point here. So it's actually something that you can do to get some free resources to take the next step. And this is the step that I want to talk about now. It's the step of automating the entire process, also the result analysis. And we did a proof of concept there in 2020 by using Keptn in a combination with Neoload and Dynatrace. And we built an automated quality gate. And before I'm gonna talk about that, I want to talk about why has this not happened before so far. So what's keeping you from automating the entire result analysis? If you're a performance tester, you care about a lot of things, right? But all these metrics are probably difficult to evaluate. So what we see is that a lot of people automated monitoring. The next step would be to automate the quality, and a lot of things are happening there. And if you take this as like a stack, see this like a stack to gain something or reach the holy grail of automated operations, where you're in the autonomous cloud and everything takes care of itself, it's a mandatory step to automate the quality. And what we see is there is like a gap from here to there, because we see automated unit tests, of course, also end-to-end tests, mostly on interface level APIs. And we see this also on, of course, browser automation, so functional tests. But actual load tests or performance tests are almost never automated. Why is this the case? If we look at the nature of a performance test, it's actually quite clear, because the decision is a lot harder. For unit test or end-to-end test, it's simple, right? You have a browser clicking through your application. If something unexpected happens, a field is not there or something, it simply fails. You can put in simple validations there. So it's a true-false decision, actually. Same goes for unit tests. In the performance tests, as we mentioned, there is these 3 pillars or 3 aspects of performance testing. It's the performance itself. So you care about response time. So the response times. You also care about error rates and stability, of course. And in addition, you care about the infrastructure you're using. So you care about the resource consumption. For instance, this could be how many pods you use, CPU usage, mainframe calls, database calls, whatever. It's hundreds of metrics that you want to look at to be sure that everything is smooth when you hit production. And this is the reason why the decision is not so simple anymore. And the entire approach is to combine all these metrics back into a final score and make this decision simple again. And this is where Keptn comes into place. Here we have an automated mechanism which takes all these metrics that we previously defined and combine it into a final score to make a simple decision again as a unit test that can either pass or fail. So let's talk more about Keptn, since we're at the Keptn user group. Of course, I do not need to talk a lot about the definition. I've seen, Andy, that you changed it recently. Now it's called the Cloud Native Application Lifecycle Orchestration. And I'm going to talk about the definition that we see, what we see for Keptn. But I think there is a lot of use cases out there. Of course, there's auto remediation use cases, etc. But as I mentioned today, we care about the automated quality gates since it's the one that we use most often. In our point of view, Keptn can do a lot of things, and it can be used for a lot of things. We see it that in principle, you can tell Keptn that something happened. You can send events to Keptn, and it can be anything. And also, Keptn can trigger events, and it can trigger anything. And since you can build your own SLI provider, you could probably even do smart home things with it. But to pick out one use case in terms of the continuous delivery, we try to build a sketch here to see where this is going. And this is one of the most awesome use cases, I think. So you have, of course, some development stages and test stages to the left, and you want to put the same stuff to the production once it's finished. So you tell Keptn, hey, there's a new version, and Keptn will make sure that it was deployed, send a deployment event. So we're basically in the world of CI/CD pipelines, or it's event driven, and this container or this service will go to production. And in the best case, you have your production monitored with Dynatrace. And so you have an AI like Davis sitting on this app and telling you, oh, with this new version, something is wrong, something is worse, and you don't reach your goals, and it has negative impact on your user experience. So you want to fix that. And you could automatically send a problem event to Keptn and make sure that this version is rollbacked automatically and hopefully fixed soon in the development stage. So this is on a simple sketch how we see the auto remediations use case.
Hey, Roman,
yeah, sure.
And I had to stay quiet because, first of all, I love hearing you talk because you obviously have a great experience, and this all comes from your customer engagements, also how you over the years kind of figured out how to automate performance. If you go back to the previous slide, and I know this is something where we need to also give Christian some credit for the animation, but Christian, here I have a little extra homework for you. I really like when the ship goes from left to right, kind of delivering it. One of the things Keptn does as part of delivery is doing automated performance testing and some chaos engineering. So you could even visualize this as the ship is kind of traversing the ocean, you could have like a wind blowing in and then some high waves. So basically really the captain is really trying to figure out and battle test the container that is on the way from dev to production if it can withstand any type of chaotic situation. It just came to mind because I know visual, it's amazing what you can do with visuals and animations to really explain a concept and use an analogy like this. So just a little thought. Christian, your homework, maybe you can bake this in, some performance testing and some chaos.
I'm sure he will.
I will think of that, of course.
I actually have a suggestion. It's awesome that you mentioned it, Andy. If we go now to the next slide. So keep this picture in mind. So magically, we will shrink this picture and put it to the upper right side of the next slide. No, we already prepared this because we see this use case now, the automated quality gates. It could be between both sides, right? So it's what you say. You have different stages where something can be checked, and this is our automated quality use case from left to right. Left is again development, and right we have the production. So we're kind of in the water in between where we have our quality gates. But what is this all about? So we have application version 1 or service version 1, some version in production, and we want to update this. So we need to develop version 2 in this case. And of course, once we develop it, we want to also do quality assurance and run some tests. And maybe there's unit tests already run on component level, also maybe performance tests, and you want to proceed to the next stage. In this case, you simply transition your application to the testing stage where you probably always run end-to-end tests in a fully integrated system, and you also run performance tests. And in the fully, let's say, production equivalent or almost production equivalent system, as it's usually the case, you figure out that there is still some performance issues. by looking at the score that I mentioned. And since it's just a true-false decision based on this score, you can actually make this decision of not proceeding to this stage automatically. You could fully integrate this in a CI/CD pipeline without human interaction needed anymore. I would not suggest to go this like immediately into a full integration approach. Have your automation, your script evaluation, your final score run a couple of times to make sure it makes sense, and then go and integrate it in real build pipelines. But this actually works. And hopefully you are able to fix your performance issues in the development stage, proceed automatically through the automated quality gates to the testing stage, and finally hit the production. So we mentioned this a couple of times. I think most of the users here heard about SLIs, SLOs, SLAs already, so I don't want to spend more than a minute with this. Just as a quick reminder, this is the language of Keptn, so to say. This is something that Google came up with, and we need to define these metrics that I talked about. It has been there like always. If you're a performance engineer, this is the performance counters that you have been gathering. It can be response time, it can be CPU, it can be anything you want. Like, you need to define your metric as an SLI, and you need to define how you want to measure it in terms of what statistical method, and you want to define some goals. And for instance, this would be the SLO. It could mean that a response time must be less than a certain value in a certain period of time. For instance, here, less than 400 milliseconds over 30 days. And if you take these, this is, so to say, the groundwork for building something greater. It's the agreement, it's the contract that you have as a service level provider with your service level consumers. And this usually involves penalties and everything, all the scenarios that can go wrong, and what happens if these goals are not fulfilled. But we mostly care for our use case now, not about the contract stuff, of course. We care about how to define our metrics and our goals. So this is already something that goes a little bit into Keptn and how it works, but it's still a view from afar. But the nice thing is that you actually don't need to understand what's below the surface, right? You can just use it. But the way it works is you can trigger the Keptn API from anywhere. It could be Jenkins build pipeline, it could be Azure DevOps, it could be simple command line, whatever. You need to trigger an event and tell Keptn that a test is running. And there is a Lighthouse service, which is quite central in Keptn and managing something like the SLI providers, or handling the communication when event comes in. And so the SLI providers can be, for instance, Dynatrace or Neoload. It's actually, in our use case, where you take your metrics from. So I'm going to talk about that in a minute more, how it's the way if you want to use your metrics from Dynatrace. It can be also Prometheus. It can be actually anything, since you can also write your own SLI provider. But for these tools, it's already there. What you end up with is actually the heat map in the Keptn's bridge. So you can, of course, analyze the goal if it's met for each individual metric, which is super important. So don't get me wrong, you don't end up with just the score and you don't know what went wrong, but the score is low. You have the details still available, of course. And this is the first site where you can, if something is red, have a look at the bridge, see what goals are not met on what metrics, but we're gonna see this in practice in a couple of minutes. So in principle, it was built on a YAML basis. So if you're a load test engineer, you probably have in your APM tool or anywhere else built some mechanism that after the test, you have your graphs, you have your metrics, you see how the test was run. You see your response times, you see your CPU times, everything you care about. And the idea is to tell now Keptn, these are the metrics that I want to evaluate. And Keptn speaks here in the language of YAML. So you have to define your SLIs, of course, and your SLOs. So to say again, what do you want to measure and what is the goal? And this is actually, in our view, it was quite maintenance heavy, as by running, I would say, minor load tests even, we ended up with YAMLs that consist of 500 lines of code. So there would be a lot of things to write. So we were like nagging Andy to, can't we do it a little bit better? So we did a little workshop there, and we came up together combined with an approach which is really, really awesome. So, and this is what you can take home with. So if you want to go this way and you have somewhere your dashboards, for instance, in Dynatrace would be a perfect case, because all you need is actually provide additional informations into the name of your charts for Keptn, and all this YAML stuff that is needed to actually perform the evaluation on the Keptn side is generated automatically. So because the metrics that you care about are the ones that you were looking always in any case here, for instance, failure rates and stuff like that. So here, for instance, you see that you want to define failure rates and as an SLI, and you want to say this is passed when it's less than 1%, and you can do this, of course, and adapt this to all your needs or what are your individual goals for your individual tests. But I don't want to talk about this too much, because I have already also prepared a demo for you to keep it a little bit more practice oriented. And before we get to the demo part, I want to talk more about the awesome integrations of load test tools like Neoload and Dynatrace, because it helps you a lot, actually. And it's quite simple. If you're a Neoload user, make sure, and your Dynatrace is also in place, make sure to hit this checkbox and simply tell where's your tenant, where's Dynatrace hosted. What will happen automatically is that Neoload requests will be tagged, so they will be easier to find in Dynatrace. And also here you will see them as request attributes. Automatically they also become renamed, so you won't be able to mix up your load test requests with actual requests coming from elsewhere. So this is an awesome feature to simply look at what you have generated and filter out all the rest, since, to be honest, you won't have production equivalent test systems just for your own for running load tests. I've never seen this. And also nice is that all the services and applications that are, so to say, under stress during your load test, they get information here that a load test has been performed automatically out of the box if you hit the checkbox. And also you get a link back to the results. So if someone else is looking at the service wondering why the load has so much increased and he's analyzing something completely different, he will see immediately, oh, there was a load test. All right, I don't have to care about this anymore. It's super important to keep things simple. And another part is, and this is quite new, it came also up last year, you can define a special tag, let's call it a magic tag in Neoload, and you'd simply tag the entry application in Dynatrace. And it means, by entry application, I mean the service in the front that you are going to put under stress. And all the services in the backend that also are important for your load test, for instance, database calls, backend services, if you have a front end, they will be automatically tagged, and you will see the dependencies of all the things that are important for your load test, which is really important for the later results analysis. In this case, it's called Triscon Testing Turf. It's our demo application, and you will have a peek at this just in a minute in the demo part. And it consists, as you can see here, maybe let's keep that in mind already, very simple web front end. I'm going to show it to you. And it's an API. It's separated in the backend, so to say, and the API and the backend calls some database. All right. Andy, do you still have some questions so far apart from that? Otherwise, I would go to the demo part.
Yeah, I think there's a couple of questions that I see in the meeting doc that I will, however, wait until the end because it's more generic in nature so far. So I think if you can do the demo, I'm looking forward to it. But again, it's great to see how there's one of the things that we try to achieve with Keptn is also we want to solve the whole tool interoperability challenge, because we see point-to-point integrations obviously with a testing tool and a monitoring tool, and I think these integrations obviously have to happen because there was nothing else before like Keptn that could actually combine them. But I think one of the things we need to think of as we go further with Keptn is how can we provide next to the cloud event protocol that we're using to trigger tools, how can we also come up with standardization around defining workloads, defining how a testing tool can integrate with the monitoring tool without maybe necessarily them knowing each other. You brought up the SLI and SLO discussion. And I know that Jürgen is also on the call, who recently started a long discussion on Twitter regarding how can we standardize SLIs and SLOs so that more people, more tools can benefit from the same definition. And yeah, it's really great to see your demo where so many tools are working together. But I think we're also just on the start to really figure out how can we all make this better integrated without having to build a lot of tool point-to-point integrations.
I'm totally with you. I think we are at the beginning of some change here. I don't want to call it transformation, since this is like a generally used word, but as soon this what we are going to show here, it really helps you to scale your load tests finally, to take out the last piece of manual interaction in most cases that prevented you from doing so far. And so this will change a lot of things. And of course, you need more feedback from production. Is like a super important topic. And also the entire SRE topic. I see a huge connection between SRE and the entire performance engineering discussion, since as you mentioned it, you want to care more about defining goals on a smaller scale, on a service scale. Exactly. So, but yeah, maybe not to keep the audience waited too much. It was a little bit of teaser now. Let's go to the demo part and also discuss this further at the end. So before showing it to you, I'm going to explain what's going to happen when I hit a button to trigger a pipeline, because there's actually a lot of things going on. But since we automated everything, all you will see is a final score, right? So I have to explain all the awesome things that are happening there. And in this case, Andy knows this slide already, and I once mentioned it, a pipeline is awesome. It's like a symphony, and many things are playing together perfectly. In the middle of it all, Keptn is sitting there orchestrating these things, and I'm gonna talk now about the demo ingredients. And we're gonna have a look at our test application, the Triscon testing turf. It's hosted on the Kubernetes cluster. Also, Keptn is sitting there. We're gonna use Neoload Web, and Dynatrace is monitoring this application. And yes, there is music playing already. Since I said a pipeline is like a symphony, I wanted to take the chance to make it even more awesome. And you're gonna have some nice music during the demo part, Andy. Cool. So we have load generators and controllers also from Neoload here, and we have Azure DevOps. This is our ingredients. So what's going to happen when I hit the button here in the pipeline, triggering the test, is that we're going to pull out our Neoload test from our Git repository, send it to Neoload Web. Neoload Web is going to hit the controller with an event and saying that we want to run a test. The controller will spin up a load generator because we want to stress our application, which is the Triscon testing turf. It's just a web front that I'm going to show you. So the system is performing now a load test, and it's constantly being monitored by Dynatrace. And you see already here a screenshot of our SLO dashboard. And after the test, we're going to send back an event that the test has been finished to the pipeline, and it will tell, thanks to an awesome plugin of Bert van der Heijden, Keptn, that the load test was finished, and we can actually evaluate it. So Keptn knows when the test was performed, pulling out automatically all these metrics to combine it into a final score, ending up in the bridge. And now I had to put it in this way because you will only see like now me hitting a button and ending up with an awesome final score. But here, this is more or less a semi-demo. It would be a video that we pre-recorded, but this would be not as awesome. So we're gonna do it in a live demo. All right, let me just grab the right window. So here you see already our dashboard. I'm gonna explain this further. And as you see here, we have a lot of links in our dashboard. The first thing is gonna be me calling the pipeline, triggering it here from Azure DevOps. I'm gonna say run pipeline, and as soon as it spins up, I'm gonna switch back and talk more about the dashboard we built. So this is already a so to say, final pipeline. We have our Neoload project and APIs and all configured. We simply say run. We could trigger this from anywhere. It could be build driven or whatever. Now I will kick off the load test manually from this pipeline. So we can have a look here. So all these things that I just mentioned are gonna be visible here in the console as well. Now Neoload will spin up and Neoload web will be informed to run the test, etc. Let's give it a little bit time, switch back to the dashboard. So what's the important thing here? We have a lot of things here visible, but we have these global goals telling us when the test should pass or fail, building on this, depending on the score. You can build your test in a comparison form where you say, I want to compare it with the last run, I want to compare it with the last 10 runs or whatever you need. And you have no restrictions there. That's the important part you want to take home with. And here we have front-end response times, which is awesome. So you can baseline, and you can do this in your load test time anyway, right? So this is something that the load test tool offers. But what the load test tool doesn't offer is back-end response times or number of database calls. So you can actually take into account many more metrics that you can have to gather in a different way elsewhere and combine it into this final score and the entire automation. So we have an application here to make it a little bit more easy for you to follow. It's a simple application. It's called the testing turf. It's a demo application actually that we built for recruiting purposes and for these purposes. And yeah, there will be a recruiting challenge available. If you're able to break the site, you will get an interview with us. Make sure to check it out on our webpage in a couple of weeks if you have interest in working with us. So what this application is good for, it's just for demo purpose. We have a simple registration process here with username, password, and you're gonna end up with the last users here in the list that were registered. So in the load test, we are simply doing this over and over again with many users, doing a lot of registrations in short time. So this is what we want to check at the end, but what is happening right now? Let's have a look at Neoload web. Neoload web is already running the test. I was able to see it here. So our pipeline mechanism was already working. And we see that the load test is already running. And we designed it to only run for a couple of minutes here, which is enough to do some proper baselining on a small scale. And we see we are facing already some errors here, which do not occur under load. Like everything seems to be awesome. I'm still here, right? I can click, everything, it's working. So why is the load test running on errors, right? So this is one of the many examples of the errors that you can only discover in load tests. And I'm going to show you just at the end what went wrong here. Let's get back, give it a little bit more time to finish. So what has been a practical approach is that you may want to think about your dashboard as your central tool for your operations. You can trigger the pipeline here. You have a link to your load test tool. You have a link to the Keptn's bridge. So we thought this could be some DashOps approach. And it is in this way, you want to have meta information available for anyone who looks at the dashboard to also make sense of it. But it's also important that this is the part that's gonna, what I want to mention, this is the part that's gonna take up most of your time, right? So this is always the case as a load test engineer, to think wisely and hardly about all the things you want to consider for your test. But as soon as you have this done, it doesn't change from one release to the other. Of course, if there's like 1,000 services that come into place with a new release, you may want to consider it. But in general, you don't have to do this. So you can define your approach, your metrics once, and benefit from this over and over again in a fully automated way. And in this case, since we are running on Kubernetes, we care about CPU usage of pods, we care about memory usage of pods, and we want to exactly know if we consume more resources from one build to the other. So let's hit back to our pipeline. Here you see the Keptn event is already, so it's already the final event, so to say. So we are waiting for Keptn to evaluate the test. And we see, this was red, we're gonna hit back to our bridge to see what went wrong. Here in Neoload Web, actually, I should already see that the test is over. I see this here. And if I don't have a look at this, I don't have to look at this, right? I want to have this in my final score. So to go back to the Keptn's bridge, we see here now, 2 minutes ago, we've finished our tests and Keptn has evaluated it. And we see that our score is not good enough. Actually, the score would be good enough, but some key metrics that always need to fulfill some certain goal, like the error rates that we really, really care about if something goes wrong. We want this test to fail even if the final score is still good. So here we see that we had some failure rates increased on the API level. And if I now want to know what went wrong, of course, I can simply go back to Neoload Web. I can have a look at Dynatrace. It would be really, really simple to find out, in this case, what went wrong. Here, for instance, I'm going to show it in Neoload Web. We have it on the events, so the requests that were failing. And we see, although everything was still performing, I was clicking through this, right? You saw it. It was still awesome. But we have here a concurrency problem. So as soon as 2 people are hitting this register button, in the same second, it goes boom. And this is not something that we just exotically came up with. It's something that we see very, very, very often, also on different customer stages. And we implemented this in a way, of course, this is on purpose, it's a demo application, but we implemented this in a way of using a static dictionary. Mm-hmm. And you're gonna see this here, it looks like this. It could be simple, a dictionary where you add the same key twice. And this happens a lot of times in production.
And I think, Roman, this also shows that, and I had to keep quiet because of the demo, and also the music is mesmerizing. It's like, and by the way, I learned today, because I'm every day in the morning, my wife and I, we're listening to the daily word, like we have an Alexa skill, and today mesmerized came up. And did you know that mesmerizing actually comes from an Austrian, his name is Mr. Messmer, who was kind of, he was kind of explaining, like, if you do something, if you do things and you basically then impact people in a hopefully positive way, that they are mesmerized. So it's, the word comes from an Austrian. I had no clue about it.
No, I had no clue about that. Yeah. Always awesome.
Yeah.
That's something new.
But to your point with the concurrency problem, right? We see this all the time as impacting applications. And the thing is, you don't even need a whole lot of load to test your service or your application against these concurrency issues. And this is also a question that often comes up. Can I actually find performance and scalability issues in applications as part of my delivery pipeline with very fast tests like you shown, or is this all just marketing, blah, blah, and you really always just need large load tests? And I think you proved it, that you can find these problems with tests that only run for a couple of minutes.
Yes, and it's awesome that you mentioned it, Andy. If you're more interested in this kind of tests, we're going to have an entire session about concurrency testing at the Neoload Packer event. I'm going to put another reference at this at the end of the presentation. I think it's on the 23rd of March. Make sure to check this out. You're absolutely right. This is something that you can only discover in performance tests, and you don't need 10,000 of users.
Yeah.
Usually you need 5 that are really synchronized, and it's easy to achieve with the right setup.
Very cool.
I've forgot to mention one thing, and the music that you just heard, I really liked it a lot. It's from Roman Häuser. It's not, my name is also Roman, but I'm Roman Ferstl. I would not be I would not be able to pull this off. It's really awesome what this guy is doing. Make sure, if you liked it, to check him out on YouTube. He's a really great composer.
Perfect.
So to conclude for today already, actually, so what is our next strategies? And if you're interested, what can you do next? So at our customer, I told you, we did a POC. We showed that it's possible. Everyone loved it. The developers loved it. So we're going to go there with the customer, and we're going to take 10 to 20 microservices in the next half year and build this fully automated quality gates. And we will end up with almost double the tests that we are able to perform now in a year, just by adding it for 10 more services. So this is a highly scalable approach. And the best thing that comes with it is that you enable others to run your test. Like if you think really hard about all the metrics that need to be considered in the load test, others don't have to do it anymore. They can just look at the score and come back to you if it's red, and if they don't understand it, and you will explain them, oh, this is the because this metric, and it comes from there. But if it's green, no one needs to care about it anymore. That is the idea about that. And of course, it helps you to build this early, to catch more problems before they hit production. That's the entire idea, right? We don't want to have these nasty concurrency things, for instance, in production. And what we showed here, I want to also stress this. It was for an end-to-end application. For a front end, you may want to start with a microservice. It's the best thing here to start with this small load tests on microservice scale, and then you can think about also evaluating bigger load tests where you have many test cases on a front end with it, but it's more complex then. So if you start this approach, start with a microservice. And this is the last slide, I think, already, where we want to give you a little guideline. So if you think about improving your performance testing, the first thing is that you want to evaluate where you stand and improve from there. If you're not ready yet for automated quality gates, it doesn't make sense to pull this off. So when we say think about where you're standing, is think about how much time you spend for script maintenance. If this is still the most amount of time in your process of performing performance tests, you want to change that. So you can change that by thinking about other tools that exist out there, which may be better. But another approach is to reuse your functional tests. You want to look around you, look at your environment, see what is there. If it's Tosca, if it's Selenium, talk to the guys, talk to your load test vendor. I'm sure there may be an awesome integration there, so you can reuse the scripts of other people. And even if you don't reuse the scripts of other people, if you write your scripts in Selenium, you can just hit the button and the browser will click through it each release, and you don't have to script and record it manually over and over again yourself. So this is a really important thing to lower your maintenance time. Another thing is that you want to utilize your APM tool, such as Dynatrace, for your test analysis if you don't have leveraged all this nice integration that we showed before. Just as a quick reminder, by doing so, these were the only measures. Yeah, we didn't do anything else, and we ended up there with already 10 times more apps that we were supporting and 15 times more tests. So if you don't have the time for automating the performance tests because there's so much to do, think about automating the steps that you do each day to improve from there. It will help you a lot. And if you have reached this point where you say, well, I actually am quite happy with my maintenance time, it's all good, I used a lot of automation there, then you're ready for automating the final step of the result analysis. And you want to start with one project, one microservice. You want to automate the test analysis, and you want to talk to your developers. You don't want to tell them, now I built the performance test, I integrated in the CI/CD pipeline, and it breaks their build each time they try to deploy something, or it breaks their pipeline. You don't want to do this. You want to first make sure that your score, your metrics make sense, that your test design is stable in anything that they say that this is awesome, I'm going to use this a lot. And then you're ready to enable this as a self-service. This is the first step. Make them be able to run the test themselves outside of the pipeline. And then if they are really happy with it, they want to have it in the pipeline anyway. And this is the final step if we want to have like a procedure here. And I don't want to pick a number what you end up with here, because if this works out, you pick the number of tests that you can do each year, because it's simply as easy as hitting a button. Final slides. Andy mentioned it already. Concurrency problems, huge topic. I'm going to talk about that more at the Neodis Pack Hero events at the 23rd and 24th of March. Make sure to check it out if you want to hear more about that. All right, this is it from us. We're Triscon. If you want to reach out to us to talk about anything related to performance or APM, this is where you find us. We're situated in Vienna. I'm on LinkedIn. My name is Robert Ferstl, and we're always happy to talk to you about all these topics. And thanks, Andy.
Thank you so much. I've heard, I think, your talk a couple of times now, but it's always great because there's always something new. I think what hit me again was your second to last slide with like your initiatives for 2021. This one here, because this is also so true for Keptn, because we have a lot of people that would like to use Keptn quality gates, but then very often they say, well, the thing is we don't yet have either tests at all, or we have tests that are constantly failing. Therefore, my quality gates are not even stable enough because I don't have the pre-work done. Yes. So this is why, I mean, even people are getting better and better, and you were saying this with test automation and building tests that are stable and executing them on a regular basis, but a lot of organizations are still not there. And this is why I really like your 7-step plan here. Start with your scripts, your script maintenance, because otherwise, if every second time the pipeline fails, you realize it's your test script that are now broken or not stable, then Keptn doesn't help you either.
Exactly. And if I would summarize it, its first thing is to look around yourself, what you are doing, try to see if you can improve from there, look around what others are doing, try to improve from that. And then if you're good to go, then this is the most important part. And thanks for mentioning it again. You want to talk to the people, and you want them to have this solution, right? You want to have a communication bridge to the people building the apps. If you are the performance tester not building the apps yourself, you want them to care about your performance test. And this is the perfect way to build a communication bridge to them, since as soon as it's easy for them, they will accept this as a valid solution.
Mm-hmm. Hey, there's a couple of questions in the Q&A section now. Rather quickly, because we are already at the 1 hour mark, but in the very beginning you mentioned memory leak testing, and so the question is, based on your experience, do you need large-scale tests that run for hours, or can we also detect memory leaks as part of your delivery like you showed today at Keptn?
Yes, that is actually a really good question. So the honest answer is that I wouldn't go for discovering memory leaks in an automated quality approach right away. First of all, you want to start with the small baseline tests where you do always exact the same things in a short time and you don't want to have your pipelines being run forever, right? So this is why it's awesome to start with a microservice where you can say, okay, I call it 1,000 of times in 5 minutes, and then you end up always with the same results. Is this enough to discover a memory leak? No, usually not. What we do is, when I started with load testing, the legacy approach is that we have an application. We need to like run 12 hours of load tests to see the potential memory leaks there. And yes, if it's a really slow decaying memory leak and you want your application to eventually or actually crash in the test, this is the way to go. But it's also important that you know how does a memory leak look like in your metrics. And if you are aware that it's mostly heap sizes, you could actually just say, and you could build this into Keptn and say, well, I'm going to run it for 10 minutes. And if I'm going to build up, I don't know, 100 megabytes of heap, and after the test, it's not cleared up, so you wait a little bit after your test, then you could say, well, it shouldn't behave like this. If you have some caching mechanisms implemented, and this is like a feature, of course, you don't want to break your build from this because it works as designed, yeah, right? You would have to run longer tests, but this is the way, this is the important thing. If you see in your first load tests that the heap is like the clear horizon on an ocean surface and it doesn't change, yeah, like perfect horizontal, yeah, you want to put a metric in there, and you want to put a goal on this that it doesn't change from one release to the other. And if this is the case, you could already estimate a memory leak in a smaller scale test, which doesn't run for hours.
Cool. I want to pick one more. You had.
Sorry for taking up so long to answering, but it's an awesome question.
Yeah, no, that's good. You had the load testing dashboard that you had. Is this something that you share with others? Are there some best practices? Do you have like a set of metrics and dashboards that you always use for, let's say, a particular type of application? Because the question comes, what can we reuse and what can we also give people as a best practice? As how do we start? Like, which metric do we choose? Which metrics do we choose for a particular application? Do you have some best practices here? Do you?
Yes. So the answer is yes. There is a certain things that you always want to care about, and it's response times usually. It's error rates, so failure rates, requests that fail, and you want to put goals on this, right? So hopefully the error rates should be 0, right? And this is something that you always want to consider. Also maybe database calls, but this is already where it becomes so, is my application doing database calls? Is it going in this direction or what? And this is this is the most awesome part of being a load test engineer, to think about the metrics that make sense. And my general answer is that yes, there is a small set of metrics that you always want to consider, such as resource consumption. You don't want to hit 100%, and response times and error rates, but you always, in each case, want to talk to the people who did the architecture or understand the entire thing to make sure that the best metrics are in your evaluation. This is something that I will always suggest.
The metrics the metrics that matter. Right? That's the goal. That's the thing.
Yes. And for instance, what we do is at the customer side, they're doing a lot of mainframe stuff I mentioned. So maybe you want to put the number of calls that you're doing to the mainframe or that's going through the mainframe through your backend. We want to put this in a metric, and you want to say, well, from one release to another, we don't want to do 10 times more, since you're going to pay probably 10 times more, right? Yeah.
Very cool. Hey, thank you so much, Roman. I want to make sure that folks that are seeing this at a later time, if you can just do me a favor and go to your last slide again with your contact details. Obviously, we'll put them also into the docs so that they can reach out to you, because just as we had last week at our Perform conference, it's a lot of offline, or in this case, online virtual discussions, but that then went to another medium with folks that wanted to learn more about you and what you do. So great way to get in touch with you, all the details, and I know you're open to discussions and share and find like-minded people.
Of course, and we do offer a lot of workshops and trainings, so we can discuss your specific needs. Of course, if you're interested in learning more about this stuff or to improve your load testing, just make sure to reach out to us. We're always happy to help. Thanks, Andy.
Thanks, Christian, for the awesome slides and for building a little chaos into your ship, into your ocean, maybe.
You're welcome. Yeah,
Yeah.
I will do this.
Yeah.
One little reminder, there is additional slide after this. If you want to use the pipeline, want to see how it's done, you can follow this link. So it's a little bit easier to start from.
Perfect. Yeah.
Awesome.
Thank you. And Jürgen, thanks to you for setting these things up and being an awesome Keptn community lead and putting the recording up also on YouTube soon.
Yeah, thanks, and thanks for the awesome demo. I really loved it.
You're welcome.
It was the first time that there was music with the demo. That was really cool.
It was the first time for us too. I'm glad it worked.
Yeah.
And I want to also say thank you for providing such a great thing. It really makes our life a lot easier, as you could see.
Good. With this, we want to say goodbye, and I'll see you soon at the next Keptn or performance-related event where we share our best practices. See you guys.
Thanks, everyone.
See ya.
Bye-bye.
Bye.
Bye-bye.